Okay, so um, solving the camel case problem here. Okay, so to start off, if you don't mind, I would just like to read the problem statement here just to get a bit of a sense of what I'm being asked to do here, right? Okay, so there's a sequence of words in camel case as a string of letters S having the following properties. Okay, so camel case, I believe this is where the first word has no capital letters, but then the first letter of every subsequent word will have will be capitalized. So here it's a concatenation of one or more words consisting of English letters. Makes sense. So you have multiple words appended to each other, and all letters in the first word are lowercase. Okay. And for each of the subsequent words, the first letter is uppercase and the rest of the letters are lowercase. Okay, this makes sense. So given S, the string, determine the number of words in S. So we have a string and we want to know how many words are inside of the string according to the properties that I just read here. And in the example, we can see we have the string 1, 2, 3. Okay, and here there are 3 words, right? Because the first word has no capital letters. So here it looks like the first time we see a capital letter, we can already assume that is the second word in here. So you have 1, 2, 3 words. Okay. And just briefly taking a look here at the description, looks like we're getting a string as an input, right? A single line containing a string, and we're supposed to return an integer here. And so just thinking about the input for a second here, am I ever, or are we ever going to be dealing with cases where maybe we get like a empty string or, you know, a string of just like one word or anything of that sort? And to answer that, I'll just look at the constraints, right? Okay, so we see the length of the string is going to be greater than or equal to 1. And for the sake of this problem, is it okay if I just assume that if I have a string, for example, of just one letter, then I can assume that that's just one word, right? I'm sure there's some one-letter words out there. Okay, so I know at least I'm not going to get an empty string. I'll have a string of at least length 1. Okay, so to start off, a couple of things that I'm thinking about here. One of them being, I'm thinking if I'm given a string, I can first, of course, I'm going to iterate through the string, right? And every time I see a capital letter, I can have some variable that gets incremented, maybe like a count variable, for example, right? And I can just increment that variable by 1 every time I see a capital letter in the string, right? And that tells me that, hey, every capital letter you see is another word. So initially, this is what I'm thinking here. So I think I can just have a variable here, right? Track new words, and this variable, I can just call it count here. Okay, and I'm initializing it to 0, but I think this is something that we might need to think about as well, because what happens if we have a only one word in our string? If we have only one word in our string, and then I say I iterate here, right? Keep thinking this is Java. I iterate through string. If there's only one letter in here and I iterate through the string, I go through it once. I don't find any capital letters in here because that's my condition to increment count, right? So I don't find any capital letters in here, then I'm just going to return count. But now we have a problem, right? This is an edge case here where if there's only one letter, technically there is one word, but count has 0. So for this case, I want to maybe start by having count set to 1, right? Increment count to 1, because I know by default, according to our constraints, I will have at least, S will be at least of length 1, right? So at the very least, I'd have one word in here. So I'm thinking here, I'll iterate through the string, and as I'm iterating through the string, there's a condition here that I'm going to be going with, right? And this condition that I'm going with is increment count for each uppercase letter seen, right? And then at the end of everything, I would just return count. So I think this is like a pretty straightforward approach. In Python, right, I can just say for L, right, for a letter in my string S. Now I'm going to go ahead and perform this action here. So I'm going to say if L dot is upper, and this is how you check if a letter is an uppercase letter in Python. So if L is upper, then what I'm going to do is say count plus equals 1. So if L is upper, then increment count by 1, and this should take care of that for me. And now, once I'm done, I can just say return count. All right. So this is what I'm thinking here. And if we have an example, right, I just want to go through just a quick example of this before running this. And yeah, maybe we can just do it up here, right? So let's say we had this example that was given here. Based on my algorithm, if it is correct, then I should also get the output 5, right? So let's say we take this word here, save changes in editor, and we say, okay, we have count, right? Count, which starts off at 1. This is here. And then we go through each letter inside of the string, right? And we say, okay, so letter, we start at S. S is not uppercase, A is not uppercase, V is not uppercase, E is not uppercase, C is uppercase. We've seen our first letter that's uppercase. Count now becomes 2. Then we continue to go ahead. No, 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 yes. So now count becomes 3. We go ahead. No, yes, right? That T for the count becomes 4. And then we go ahead. H is lowercase, E is lowercase. Now this E is uppercase. So count becomes 5. And then we continue to iterate through all these letters and find out, okay, there's no other uppercase letters. Our count is now 5. We go ahead and return count. So I think this looks good so far. I would like to give this a run, you know, against the edge cases or test cases and see how it does, right? So let's say we run this code against our initial test case. Okay, this goes ahead and this runs. And before submitting it, just want to discuss some of the big old complexities, if, you know, for lack of a better word here, right? But we can see here that in terms of memory, this is just constant, right? I'm initializing one variable count, and it's this variable, right? It's not growing. It's not like I'm not allocating memory for every letter inside of this string, right? So my variable here is not growing proportionally with, like, for example, my input here, as where I would have maybe like an O of n, big O of n space complexity, right? This is constant. It remains like this regardless of the size of my input. Now, in terms of time complexity, I know that I'm going to have to go through every letter inside of this string. And so, you know, this looks to me like a big O of n time complexity, because where n is the length of my input. So in this case, the length of how many letters are inside of this string, and that would be the complexity. So maybe I can just write that here. Not necessary, but we can say like space complexity. This will be big O of 1, constant, right? And we can say time complexity. We can say this is big O of n. And now let's go ahead and submit this and see how we do. Cool. Looks like we went ahead and successfully passed all these test cases. And that'll be all for today.